Hello and welcome in to the example video for lesson 3 for Precalculus 1. In this video, we're going to look at, what do we got here? I think four examples of how we can graph our trig graphs depending on what function we are given. Let me share the document camera here. Okay, so for all of these, we're going to want to state the amplitude, period, phase shift, if there is any, and the thing that gives most people trouble usually is the sketching. Sketch it. So first we have y equals cosine of 2 pi x. So for amplitude, it's what? It's the absolute value of the number in front of the function. So the number in front of the function is 1, so absolute value of 1 is 1, meaning this graph will go as high as positive 1, as low as negative 1. For period, well, remember back, our period for cosine is what? 2 pi over k. What is k? K is the value in front of x, or if I have a phase shift and there's a parentheses there, the number in front of the parenthesis. Now, if there's a number inside the parenthesis, and I should have made that a little clearer on the content video, then we need to factor out whatever value it is so that x is by itself inside the parentheses. In this case, there's no parentheses, so it's just the value in front of x, which is 2 pi. So my period is 2 pi divided by 2 pi, which is also 1. So on the graph from 0 to 1, that's how long it takes the cosine curve to make one full cycle. And then phase shift, well, there is no parenthesis, there is no plus or minus in there. So in this case, there is no parenthesis. So when I sketch these things, what I will usually do is draw the x-axis, the horizontal line. And then in this case, there's no reflection. So it's just going to look like a normal cosine curve. So I'll draw it in dotted line there. And then typically cosine starts at what? It normally starts at 0, hits the bottom at pi, and ends at 2 pi. But to figure out what these values are on this curve, what I need to do is divide by k. And so my k is 2 pi, so I need to divide by 2 pi. So 0 divided by 2 pi is 0. Pi divided by 2 pi, well, the pi's cancel and I get 1/2. And 2 pi divided by 2 pi is 1, meaning I'm starting at 0. So I should say too, if there was a phase shift, then I would have to add or subtract phase shift to this. But since there's no phase shift, this is my final answer for the graph. So I'm starting at 0, it hits the bottom at 1/2, and then it ends at 1. And so because I know 0 is here, now I can draw on the vertical axis. I know it gets as high as positive 1, as low as negative 1, and then go ahead and just fill in the curve at that point. And again, you could probably draw it as a solid line at the start as long as you're not going to be doing any. If you solve it that way, then you can just draw it in from the start. Some people like to draw the basic one, then start doing your shrinking, expanding, reflecting, shifting. but then it starts getting real messy because you'll have a bunch of curves on there. So I find this to be the easiest way. List out your normal points, divide by k, and then add or subtract your phase shift if there is any, which of course in this case we didn't have any. Whoops, not one, two. Let's say we have y equals -2 sine of 2x plus pi over 2. So this is where I am talking about that before I can do anything, I can't figure out amplitude, I can't figure out period, I can't figure out phase shift because I have this 2 inside of here. That's a big no-no. If you look back at our equation, our standard equation for sine and cosine, inside here, what? There was a 1 in front of the x, and there has to be a 1 in front of the x if it's in the parentheses. So what I need to do then to get x by itself is what? I need to factor out a 2. So when I factor out a 2, I have to factor it out 2 by everything. So divide this by 2, divide that by 2. So I take out a 2 and I'm left with x plus pi over 4. Now, if factoring is not your strong suit, I would just double check, distribute back. 2 times x is 2x. 2 times pi over 4, well, the 2 cancels with the 4 gives me 2, so pi over 2. So yes, I get the same thing. Now, this is the equation that I'm going to use for all my work. So first, amplitude. Well, it's the absolute value of the the number in front. So absolute value of -2, which is +2. But what I'm going to also do here is because of that negative sign, it's going to flip the curve, flip the graph. Remember, again, on your transformations from Precalculus 1, if there's a negative in front, it flips it on the x-axis. So this is going to flip the sine curve when I sketch this out. My period is 2 pi over k, which in this case, 2 is my k. So therefore, this thing makes a complete cycle in the distance of pi. It shrunk it down, it squished it. And then phase shift, well, I see plus pi over 4, so my phase shift is minus pi over 4. So I have a lot going on with this curve. The first one was pretty straightforward. This one is a bit tricky. So it does what? It's making it taller and making it go lower by just a factor of 2. It's flipping it, and it's also shifting it over to the left. So now, so that's our 3 values there, but let's sketch it. And so this is why I said, well, the way I like to do these, draw your horizontal line, then draw the curve without any vertical lines at this point. So it's a sine curve, which would normally look like what? It would normally look like that. But because of this minus, it flips it. So instead of going up, down, and back up, now it's going to go down, up through the x-axis, and end here. So it's the sine curve, but flip it on the x-axis. And normally, sine does what? It normally starts at 0, crosses through at pi, and ends at 2 pi. But because of all these transformations, the first thing I need to do is divide by k. So I'm going to divide by 2. So 0 divided by 2 is 0. Pi divided by 2 is pi over 2. And 2 pi divided by 2 is pi. And here's a little trick for you. If we've been doing all this right, when I divide this by k, this value here for my sine and cosine, and secant and cosecant actually, should end up the same as what I stated the period was. The period is pi, so when I do all this division, this should end up at pi. But now I have the phase shift. I have to subtract pi over 4 from everything. So 0 minus pi over 4 is minus pi over 4. Pi over 2 minus pi over 4 is positive pi over 4. So 1/2 minus a fourth is a fourth. 1 minus a fourth is 3/4. So this becomes 3 pi over 4. And this last row is these points up here. So this is now starting at negative pi over 4. This is crossing through at positive pi over 4. And this is ending at 3 pi over 4. Meaning 0 is over here between negative pi over 4 and pi over 4. And the graph is going as high as 2 and as low as negative 2. So on a test, this is what you will be expected to do. Sketch it out, label these points where it's touching the x-axis, and then don't forget your amplitude on the y-axis. So that's that guy. That's how we would sketch that one. What if I have y equals 5 tangent of 2x? All right, so my amplitude is the absolute value of the number in front, so 5. And as we'll see here, with tangent and cotangent curves, amplitude doesn't really do a lot. It either like makes it a little skinnier or a little flatter, but that's about all that. And because we're sketching it, it's not like I'm going to sit there with a ruler when I'm grading your test, like, oh, this should have been a little taller, or this should have been a little lower. What I want to know is, does the graph look like what it should look like? So amplitude is 5, period. Well, this is tangent, so it's pi over k. And now my k is 2, so pi over 2. And there is no phase shift. You're only expected to graph one period of all these graphs. So when I say sketch it, you're just sketching one period. It's not flipped. Yes, it's a factor of 5, but it's still going to have this look to it because it's a tangent graph. And then normally, and we do the same thing, normally I start at negative pi over 2, I cross through at 0, I end at pi over 2, but I have a change in the period, so divide by k, which is divide by 2. So negative pi over 2 divided by 2 is negative pi over 4. 0 divided by 4 is 2 is still 0, and pi over 2 divided by 2, is pi over 4. And there's no phase shift, so that's what these values are here. Negative pi over 4 is where this starts. It crosses through at 0, and it ends at positive pi over 4. So there you go. You've sketched that equation. And then lastly, just for illustrative purposes, let's say we have 3 cosecant of x. So my amplitude, absolute value of the number in front, absolute value of 3, which is 3, period. Well, for cosecant, that's like sine. And so it's 2 pi over k. And my k in this case is just a 1, so 2 pi. And again, there's no phase shift. So cosecant, it's like sine, so I'm going to lightly, and it's not reflected, so I'm going to lightly sketch my sine curve, draw in the asymptotes everywhere that this hits the x-axis. Draw my parabolas inside these asymptotes. So that's what it looks like. Because there's no period change, this is just going to be 0, pi, and 2 pi. And the only thing that I really have to mark on here that's different is the amplitude is 3. So this point here is positive 3. The bottom of this curve is negative 3. But aside from that, everything else is pretty much standard for a cosecant curve. So hopefully that gives you guys enough insight what you need to do on these. So good luck on the mastery sets, and we'll see you guys in class, or we'll see you back here on video for lesson 4.